Right, so we are going to look at the second state space search technique today, which is called branch and bound. This again, like I mentioned, is a state space search technique, meaning you have a state space tree which hierarchically depicts the different states your problem can be in, and you are going to explore that state space using some logic, which is what this technique is going to be about. So before going into what branch and bound is about, one thing we need to know is what is a heuristic. Now, a heuristic is a problem-specific shortcut that intends to find a good enough solution quickly, not necessarily the optimal one. So, in simple terms, a heuristic is something like a strategy or a logic or a tactic which helps you to find a solution to the problem. A said solution need not be the best, the most optimal. It should be a valid, correct solution. That's the only requirement. And using this heuristic, we should be able to find the solution fast. So why do we need this? I'll tell you. But before that, to give you an example of heuristic, if you remember, we were doing greedy choices. We did something called the interval scheduling problem. We looked at 4 greedy choices there. I think earliest start first, earliest end first, shortest job first, and fewest overlaps or fewest conflicts first. So each of these is a logic which helps you pick one interval or one job at a time. One of these we saw is the correct logic, which will always give you an optimal solution. The others, we looked at counter examples which made us understand that in some cases these ideas or these strategies are not logically sound. Now any of these qualifies as a heuristic, because using any of these logics or strategies or heuristics, you can pick a sequence of intervals which do not overlap. Of course, if you use the correct heuristic, you will get the optimal solution. So if at our interval scheduling example, if you use earliest end time first, which I think was the one we proved to be right, you will get the optimal set of jobs or intervals. If you use anything else, earliest start or fewest conflicts or something, you will get a set of non-overlapping intervals which may or may not be optimal, but it is still a valid solution. Valid in the sense none of the intervals is overlapping with any other. So that is what we mean by a heuristic, a logic which helps you arrive at a valid solution to a problem quickly. The solution must be valid, it should be correct, but it may or may not be optimal. So that is what a heuristic is. Similarly, if you take your knapsack problem, heaviest object, lightest object. So basically any greedy choice which you make, right or wrong, qualifies as a heuristic, and there are other logics or other strategies which will also qualify as a heuristic. In simple terms, heuristic is some logic which helps you arrive at a solution, a valid solution which need not be optimal. But why do we need a heuristic? Because most of the time we are focused on finding the optimal solution. How is a heuristic going to help? So now, if you remember backtracking, what we did was we explored all possibilities in the state space tree one by one, and whenever you encountered something which is invalid, you pruned that, but all the valid states had to be explored. So if you remember that password guessing example, whenever you saw an invalid number 110 or 111, something which had less than 2 zeros, we pruned that branch, we did not proceed, but all other valid options had to be explored fully. Now what if your state space tree has a lot of valid options? It's going to become very expensive to have to explore each of them, right? So within the valid options, is it possible to do some more pruning, some more filtering? That is where a heuristic helps. So a heuristic gives you an answer, a solution. So anything that is worse than the heuristic, even if it is valid, you do not need to explore it. I repeat, a heuristic gives you a valid solution to a problem. Now if you are looking for the optimal solution and you are exploring the states, any solution which looks worse than the heuristic, even if it is valid, you can prune it or you can filter it, you do not need to expand. For example, if you are taking some heuristic, let's say you take fewest conflicts first for the interval problem, and that answer has 3 intervals, then you will only explore those choices which give you 3, 4 or more intervals. You will not at all look at any option which has fewer than 3 examples. Of course, that is not exactly a state space problem, but it can be modeled as such. And coming to your knapsack problem again, let's say you choose some greedy choice, heaviest object first or most profitable object first, for example. So if you are making that greedy choice at every step, let us say at the end your maximum profit collected is 25 units. Then if any other combination of objects picked is going to give you less than equal to 24 units, and you are able to see that a few steps ahead, you can prune those branches. You do not need to explore them at all, even though they are valid combinations. So this is what a heuristic does. It helps you to filter out some choices from within the valid set of choices. So the number of states you have to explore is reduced, so your time and space complexity are going to get better. So now the better your heuristic, the more unnecessary options are filtered out, the fewer options you have to explore, and the faster you're going to reach your answer. So that's what a heuristic is.